Assalamualaikum viewers. In this playlist, we will discuss about matrix mechanics. Before moving ahead, let's have a quick view on the formulation of quantum mechanics and some basic terminologies to understand matrix mechanics more clearly. Formulation of quantum mechanics. There are primarily two major formulations of quantum mechanics: matrix mechanics and Schrodinger mechanics. Matrix mechanics. It was developed by Werner Heisenberg. This formulation uses matrices to represent observables and state vectors. Schrodinger mechanics. It was developed by Erwin Schrodinger. This formulation uses wave functions to describe the probability of finding a particle in a given state. While these are the most common formulations, there are also other approaches, such as path integral formulation. It was developed by Richard Feynman. This formulation considers all possible paths a particle can take and sums over their contributions. Another is density matrix formulation. This formulation is useful for describing systems where the complete quantum state is unknown or inaccessible. Dirac notation. It was developed by Paul Dirac. It is often used in conjunction with matrix mechanics and Schrodinger mechanics, providing a more abstract and general way to represent quantum concepts. It's particularly useful for understanding the mathematical structure of quantum mechanics and for performing calculations involving quantum states and operators. It is important to note that these formulations are mathematically equivalent, meaning they lead to the same physical predictions. The choice of formulation often depends on the specific problem being considered and mathematical tools that are most convenient for that particular situation. Matrix mechanics versus Schrodinger mechanics. Matrix mechanics and Schrodinger mechanics are two equal formulations of quantum mechanics, each providing a distinct mathematical framework to describe the behavior of quantum states. While they appear different on the surface, they ultimately lead to the same physical predictions. Matrix mechanics was developed by Werner Heisenberg, while the Schrodinger mechanics was developed by Erwin Schrodinger. The mathematical foundation of matrix mechanics is linear algebra plus matrices, while for the Schrodinger mechanics, the mathematical foundation is differential equations. Approach. Matrix mechanics mainly focuses on the observable quantities, example, position, momentum, and their relationship through matrices, while Schrodinger mechanics focuses on wave function that describes the probability amplitude of finding a particle at a given point in space. Key concepts. In matrix mechanics, observables are represented by Hermitian matrices, and the state of a system is described by column vector. or a state vector. We will discuss later about Hermitian matrices. While the key concept of Schrodinger mechanics is the wave function satisfies the Schrodinger equation, which is a partial differential equation. Time evolution. The time evolution of a state vector is governed by Heisenberg equation of motion, while the time evolution of wave function is governed by the Schrodinger equation. Are they really equivalent? Despite their apparent differences, matrix mechanics and Schrodinger mechanics are mathematically equivalent. This equivalence was demonstrated through dirac notation by Paul Dirac, who showed that they can be derived from each other through a transformation known as Fourier transformation. Inshallah, we will meet again with some basic terminologies of matrix mechanics. Stay tuned, stay blessed.